Good morning. I am Dr. A. Kalai Selvi. Today I present the topic backtracking and local search. In CSV, variable assignments are cumulative. For example, WA is equal to red and then NTC equal to green is the same as NT is equal to green, then WA is equal to red. We only need to consider assignments to a single variable at each level. That is, we fix the order of assignments. Which one is first, the next one. Then in a backtracking, we use the depth first search for CSV with a single variable assignment. That is called backtracking search. The pseudocode for backtracking is function backtracking of search, then CSV returns solution or failure. Returns recursive backtracking, that returns CSV. That is function recursive backtracking assigns the value, return a solution or failure. If assignment is complete, then it returns assignment. The variable select unassigned variable, then it is one of the part of CSV. For each value in order, domain values one by one. If the value is consistent with the assignment, then given the constraints given in the corresponding consistent. Add the value in the variable in the value to assignment. The result of recurrence backtracking is in the assignment of CSV. If the result is not failure, then it returns the result. Otherwise, it is failures. It removes the assignment value from the assignment. It will be repeatedly checked, and there is no result or failure. The final result is either obtain a goal state or not. It is the corresponding feature. The problem in ordering is how should we order variables for assignment? How should we order values from the domain? That is need improving backtracking efficiency ordering. The backtracking improving efficiency ordering is how should we order variables for assignment? How should we order values from the domain? That is filtering. We can detect inevitable failures early. That is, early detection in failure is must. This is another example. That is another backtracking, early version of backtracking algorithm. It is a recursive algorithm. It is defined by itself. That is function recursive backtracking of assignment. Then if a assignment is complete, then return the assignment. If a variable is select unassigned variable, then it is in the CSV. For each value in order of domain value, if the value is consistent with assignment, given constraint is satisfied. So it is added with the assignment. The result is equal to recursive backtracking of assignment. If result is not failure, then it returns the result. It is not a failure, so it must be it reaches the goal state. So the value is removed from the assignment, then return failure. The simplest form of consistent propagation makes each pair of variable consistent. That is, extends to y is consistent if and only for every value of x there is some allowed value of y. So this is the form of a picture. It is also this modified version of this picture. The problem structure is Tasmania and the mainland or separate structures. We can also solve them independently. and then combined their solutions. More generally, we can decompose the CSP into separate connected components, that is subproblems. The subproblems are combined together. Then the solution is the union of subproblem solutions. This is the picture. Algorithm for tree structures. Choose one variable as root. Order variables from root to leaves such that every node's parents precedes it in the ordering. That is backward removal phase. That is each arc consistency starting from the rightmost node and going backwards. Forward assignment phase. Select an element from the domain of each variable going left to right. We are guaranteed that there will be a valid assignment because each arc is consistent. Then the next one is local search. It improves what you have until you can't make it better. Generally much faster and more memory efficient than backtracking search. Start with an initial assignment of variables to values. Allow states with unsatisfied constraints. Attempt to improve states by assigning variable values. This is the picture with a h value. That is, number of conflicts is h is equal to 5 means this is the first picture. Then next h is equal to 2, next h is equal to 0. Next one is hill climbing search. In each iteration, randomly select any complex variables and choose value that violates the fewest constraints. That is, attempts to greatly minimize total number of violated constraints. H is equal to number of conflicts. Local, that is the problem, local minima h is equal to 1 means this is the picture. Thank you.